Okay, so I'll be saying a few words about the implementation experience of doing SPB. So, what's the first slide?
Incentives.
Incentives. Okay, a benchmark is also always a set of trick questions, and a benchmark always influences you to do certain things. And there's always a certain bunch of lessons that the authors of the benchmark intend to impart to the audience. And in our case, we provide incentives for the following. Okay, structured RDF is an important thing. We see that as playing a major part in the future of RDF and schema-less technology in general. So I'll say a couple of words about that. And then there's query optimization. People have, for the whole length of the existence of RDF, they've been complaining about the number of self-joins and how this makes execution and especially optimization difficult. So one is incented to make better query optimization, better plans, but also make them faster, because in many RDF workloads we find that query optimization times are a very significant component in the latency. And then of course there is always benchmarks imply scalability, so one should have consistent behavior when changing the scale of the data. So these are the main topics that this benchmark addresses. Okay, next one.
Inference.
Right, okay, inference. Okay, people associate RDF with inference, but in the field we don't see that much inference, and we don't see very complicated inference. So the initial inference that we have in SPB is rather modest. It's a subclass, subproperty, a few subclasses, not deep hierarchies either. It kind of corresponds to what's out there in the field. It's conveniently implementable. Backward chaining or forward chaining doesn't make much difference. It is not particularly demanding on the inference side. If we were to make it more demanding on the inference side, probably we would have, let's say, unions and possibly transitivities and things like that. So anything that's in any way related by any number of steps to that thing and ranked by the number of steps and ranked by the number, that kind of relationship. I guess that would be a way of complicating it further, and that's something that I'm looking forward to discussing with OntoText, exactly what kind of inference it should be, but there's somewhere to go to.
But
right.
Ranked by the number of steps would not be.
No, that's not OWL, but that is something that would be very useful for a practical use case. So there's something to be discussed concerning that. And okay, so much about the inference. Next.
Structure awareness.
So okay, structure awareness. Okay, so that's a thing that we've been promoting and implementing also in recent days, albeit we are not publishing results yet with this. But so it's a question of eliminating the performance penalties that are traditionally associated with RDF and schema lastness in general. So if everything is triples, you get lots of possible join orders, and you get lots of self-joins at execution time. But if you put everything that has the same subject together for all the densely populated object values, then what you get is effectively tables. And then, okay, on top of the tables, you may allow some exceptions. So you do retain the schema lastness and schema freedom and the runtime typing and all of that people have come to expect. But by and large, when it's regular, and it often is, you get relational performance, and then all these problems of doing query optimization with infinite explosive search spaces, because you got 18 triple patterns, and then you get exponential plus factorial of 18, and that's too much. And then that becomes very manageable again. Execution also becomes manageable again. And so this, I think, is a direction whose validity will also be demonstrated by this workload. So that's one of the, let's say, messages that are encoded in the formulation. All right, so next one.
Scaling.
Right, so scaling. Typically these publishing databases are not very big. So the unit scale is 50 million triples, that's small. You can scale it basically in doubles. So we are presently now finalizing the workload mix so that we indeed have logarithmic queries in one bucket and linear ones in the other bucket. And we get like a predictable behavior of these queries. As for the data, it's actually lots of literals. This almost requires the use of full text index. So literals are the biggest thing. After that, you have the full text index for them. After that, you have the URI names. And finally, you only have the quads, the RDF stuff, which in the Virtuoso implementation at 1.6 billion triples is rather tiny, like 20–15% of the data volume is actually triples. So the working set by and large consists of other things. And this is not unrealistic. It happens in practice too. And okay, ways of compressing away certain of these things will be also, incented by this benchmark. So we shall see this when we deploy structured RDF for this workload. And okay, so in general comments, this is the end of the slides. I'd say the queries, they're medium difficult. They are easier than doing TPCH in Sparkle. Doing TPCH in Sparkle is very difficult because of this. It's hard enough to do in SQL, but Sparkle is much harder because getting the right plan is almost impossible due to problems of cardinality estimation and stuff like that. So this is not as hard as that, but it's kind of medium hard. And what we see is we do benefit from smart query plans. So if you do restrictive hash joins and put restrictive joins on the hash build side and stuff like that that you expect to do in, let's say, relational analytics. Well, you can do that with RDF too. And it does cut your run times, but it drives up the compile times. And so this is one of the remarks. In fact, we have situations where you turn on smarter query optimization. Things get slower because optimization times increase, but run times decrease, but optimization time increase is larger. So these are the RDFE specifics that one encounters when implementing this benchmark, but they're kind of manageable. This is not overly difficult. So I think it is attractive to certainly the first target audience, which is the set of RDF database vendors, and then how this might be generalized to address other types of systems is something that we'll see, and that this freestyle data model business is more covered by the social network one, and we'll be talking about that later. So that's it. Thank you.
Thanks, Orri.
Okay.
I think this is the last one about semantic publishing, or not? Am I correct? So if there are any questions that remain on semantic publishing?
So you keep mentioning that the queries in this SVD take between log and linear time.
Yeah.
With respect to the data set size.
With respect to data set size, yeah.
But I'm wondering if this is also related to the size of the intermediate result sets produced during query evaluation. So are we to assume that these queries are also scalable with respect to the intermediate results?
Well, the intermediate result sets, the cases where you get large intermediates is where you have a high cardinality group by, for example.
Yeah.
Right, and that sort of thing occurs here moderately because the possible grouping keys are things like tags. And when you increase the dataset size, these tend to increase logarithmically.
Okay.
So then the really high cardinality group buys don't really occur to an extreme here. You have more of that in TPCH, let's say, than here.
But in any case, I mean, intermediate result sizes, the complexity of those are not expected to exceed those of the base relations or the base data. Otherwise, you have queries that apparently are spiraling out of control. So, I mean, the original statement of queries that with respect to data sizes are linear or logarithmic would not be changed by considerations on the the intermediate result sizes. They would follow the dataset sizes.
I mean, I may not agree with that, but that kind of answers my next question. Is it what you observe in practice, like in production workloads, or?
Sure.
Yeah.
Well, in production, we seldom observe very, very high cardinality group buys. So they're in the million, they're not in the billions. And it it is rare to have business questions like give me the subjects in order of decreasing number of properties or stuff like that. And there you would get into very high cardinalities, and you would run out of space on the group by temporary structures, and you'd have to do that streaming or ordered or stuff like that. But that's not what we see with RDF generally.
But even in those examples that you mentioned, so large cardinality group buys, that would still be in the same order of magnitude as the dataset size. So it would not exceed that size. Or if we talk about the linear query and dataset size, even the worst kind of group by would still be linear in dataset size.
It would indeed, and things that are above linear in dataset group bys that are on two unrelated things that would be quadratic in dataset size, we don't see that. They don't make a lot of sense also in terms of practical workloads. So we don't see them, and these benchmarks do not contain any. In graph analytics, you might say you might explore something of the sort, but that's outside of the query workloads.